Hi everybody, and welcome to another Arduino tutorial video supported by RS Components. Today we're going to look at the Arduino Wi-Fi Shield. It's a module that you can connect to your Arduino that allows the Arduino board to connect to a Wi-Fi network and then connect to the internet. And we can make all sorts of devices using this tool. Today, the example I'm going to show you, it's a simple lamp that changes color depending on messages that are posted on Twitter. So if somebody posts a Twitter message that begins with the hashtag Arduino RGB and then followed by a color represented as a 6-digit hexadecimal number. This is the way, for example, that colors are represented within HTML pages. The 6 digits represents the amount of red, green and blue that goes into the color. The first 2 digits represent the amount of red, the second 2 green, and the last 2 blue. So what the Arduino is going to do is going to connect to Twitter, launch a search, and it will search for all the messages that contain this hashtag, and once it finds one, it will actually go search for the number, and then it will basically take every number, decode it, and turn it into an amount of color that will be represented on the RGB LED that you see here on the circuit. Let's have a look at the circuit. Here we have an Arduino Uno with a Wi-Fi module mounted on top of it. And then very simply we took a small RGB LED and we connected 3 resistors, and the 3 resistors go to pin 3, 5 and 6. There are PWM pins. So these pins are able to control the brightness of each individual channel in the RGB LED. So the module that you see on the top here is the Arduino Wi-Fi Shield. The Arduino Wi-Fi Shield is actually a quite interesting device. It's made of this large chip in the middle. It's a 32-bit microcontroller that contains the whole software that's needed to process the Wi-Fi messages and connect to the internet and provide you with the whole networking stack. And it speaks to this little square module in the corner. That one, it's essentially the wireless part that communicates with the actual Wi-Fi network. So by using a powerful processor on board of the Shield, we can actually save code space, we can save memory on the main Arduino board. So let's have a look at the code. So in order to use the Arduino Wi-Fi Shield, we include the Wi-Fi library, and then we have at the beginning a couple of strings that represent the name of the wireless network we're connected to. So at this moment we're connected to a network that doesn't require a password, so what it says, the next parameter contains just a password that we're not going to use later. Then I have 3 pins, pin R, G, and B. These variables, they contain the number of the pins where the different LEDs are connected to. Then this constant max tweets indicates the amount of tweets returned by a search. I have to specify that most of the code that you see here actually comes from an example that was written by Limor Fried for the Adafruit Internet of Things printer. And I took this code and I removed the part that prints to the actual printer, and I replaced it with a simple piece of code that parses the information. There's another number of parameters that indicate how many times the frequency used by the Arduino to connect to Twitter. So in this case, for example, we're connecting every 10 seconds. And the timeout, so the maximum time, we will retry to connect to the server before we stop connecting. And the timeout, so the maximum time to wait from data from the server. So there's a number of internal parameters that are maybe too long to explain right now. So we create a Wi-Fi client, we specify the server name, we specify the query string, in this case Arduino RGB. Then I'm going to skip this rest of the code just to show you quickly how easy it is to connect to the Wi-Fi. So here We check if the Wi-Fi shield is actually mounted on the board. Then we check if we're connected. And then we just basically say Wi-Fi.begin SSID. If I need to specify a password, here after the comment, you see I can put comma pass, and that will specify SSID and password. And then we wait for 10 seconds. And that should be enough for a connection. And this is going to try and retry to connect to the Wi-Fi network until we're connected. Print Wi-Fi status will tell us, okay, you're connected, this is your IP number, this is the network you're connected to, and everything else. And then during the loop, what we're going to do, we're just going to create a connection to the server. We're going to send the request. This code I'm highlighting now is the one that sends the request to the server. Oops. And then later on, once the data is being received, it says here processing results. So we go to this function called JSON parse. JSON parse does quite a lot of work in processing the data that comes from the server, but what's interesting for us is here. Basically, I'm saying if the length of the message that we received is less than 20, it means that the message is short enough to be the hashtag plus the color. So I'm going to decode the color, print out the values I'm going to send to the LED, and I'm using analog write to set the color of each channel of the LED. And then we're just going to print some other debugging information if we want to know that everything worked out. And then we're going to reset the timestamp so that we can check in again 10 seconds. So here I'm going to bring in the debugging message. So if Davide, can you please send a tweet? So we're going to ask our friend Davide to send a tweet with a color, maybe send FF0000, so that represents the full red color. So now the tweet has been sent. It's going to take us a few seconds before Twitter stores the tweet and makes it available in the search. So at the moment you can see the log is just saying that it's waiting for results, there's no new result, pausing. At the moment it's connecting every 10 seconds. So a message has been received, and you can see that there was a message Arduino RGB FF0000, and our LED, it's now red. So based on this code, you can develop all sorts of other applications. So this could not be a lamp, this could be, for example, the watering your plants in the garden, or this could be the heating in your mountain home, or something like that. So we could attach almost anything to this Arduino and make it Wi-Fi enabled. So thank you for joining us. I hope you enjoyed this project. And remember, build it, hack it, and share it, because Arduino is you.